Hi there, my name's Gus. I'm a student here at the University of Lincoln, and today I'm here at the Isaac Newton building to take a look at the Cutting Edge Laser Labs. Come take a look. Colin, thanks for talking to me today.
That's absolutely fine.
So tell us a bit about what you do here in the lab.
Okay, so this lab is specifically for use of high power lasers. We use lasers in here for all sorts of reasons. So we use them for playing with polymers. We use them for measuring things, whether it be motion or sometimes chemical elements.
How great a tool is stuff like this and the rest of the lab for teaching students here at the university?
So we often use another machine behind me to help them understand the control of optics and also modulating the level of laser power compared to the amount of speed at which we track around.
So how does this pertain to the industry then?
They had been wanting in industry for about 20 years now to move away from tooling. Tooling is expensive. I've got a laser, I'd love to use it to seal trays because then we wouldn't need this tooling. The reason being, one of these tools up here, if you want to buy a brand new one for a different shaped tray, it's £100,000 to £150,000, okay? So that's why you don't get Christmas tree shaped trays at Christmas, okay? It's as simple as that.
Right.
But what I really love is a system where there's no tooling and they could just have, oh, okay, going to do a round tray now, followed by 2 square trays, followed by another round tray. So flexible manufacturing. So I keep on waving this at you. Let's actually walk it through and use this as a guide. So it goes in, you notice this is curved, and that's because it's more difficult for the light to bounce all the way out and hurt someone. It goes in, it trickles through this conveyor all the way along. So now it's arrived at this point. You can see a tray ready. And then at this point, I can't say how, we're gonna image that tray. And what that image is going to do, it's going to work out critical geometry that we need to basically track the laser around. Once it's understood that, we move the tray further on and it comes to sit underneath here, and in between this big clamp here we're holding film. What we do is we push the film down. We've got some special geometry under here to hold the film in a controlled way so you don't get wrinkles all over the place, which are a big problem for us. And then we bomb the laser around in a certain way that we control, and then we change that laser property so we can then cut the film afterwards. The problem we have is, yes, we can seal quick, but now maybe we can't cut so fast. So we've got more research ahead to try and scratch our heads. Well, is there some sort of better way? Could we do something clever with the light? Well, we've got a few ideas, so I'm not going to divulge those to you. But the tray now has made it through, out, and then it's delivered as a completely sealed package tray ready to be delivered to a supermarket. It's just a demonstration of how flexible laser systems can be. Industry 4 requires that we sort of move away from tooling. All tooling does is it applies energy in a very sort of controlled fashion to cause stuff to change. Tooling's really restrictive, you don't have any flexibility. And we can do that with direct energy. And an easy way of controlling and directing energy is for a beam of light. And that's because we can modulate the power, we can steer it with mirrors or with lenses. So it gives us lots of control, and that's exactly what we're trying to do here. We like to think this space hasn't got the most high-tech lasers, it hasn't got the most lasers, it hasn't got the most powerful lasers, but the lasers we have here are applicable, usable by industry, and it's our task to try and make sure that people can actually benefit from them. So it's just a question of us having enough imagination and creativity to think of ways of applying these lasers for societal benefit. That's really what we're about here at Lincoln.
Thank you for showing me around.
Absolutely fine. Come back, we're doing more soon.
Definitely will, definitely will.